The universe is a vast and silent place. It stretches out farther than we can possibly imagine. Speckled across this immense darkness are countless stars like tiny diamonds on black velvet. Around many of these stars, planets circle in a quiet cosmic dance. For centuries we have looked up at the night sky, filled with a deep and profound wonder. We have asked questions about our place in this grand design. We have long sought to understand the worlds that share our solar system, our cosmic neighborhood. Each one holds its own secrets, waiting patiently to be discovered. One of the most enigmatic of these worlds is Neptune. It is a distant giant, so far away that it appears as just a faint speck of light through most telescopes. For a long time, it was known to us only as a deep blue dot, a mysterious orb at the edge of our solar system. Its colour reminded us of our own oceans, yet it is a world entirely different from our own. We knew it was cold, and we knew it was windy, but much of its true nature remained shrouded in mystery, hidden by the immense distance and the limitations of our instruments. It was a world of speculation and theory, a faint whisper from the cosmos. The first and only time we visited Neptune up close was in 1989. The Voyager 2 spacecraft flew past, giving us a fleeting glimpse of this remote world. The images it sent back were breathtaking. They showed a vibrant blue planet, streaked with wispy white clouds and marked by a great dark storm. For decades, these images defined our understanding of Neptune. They were our only direct look at this icy giant. They told a story of a dynamic, active world, but it was an incomplete story. We were left with more questions than answers, our curiosity piqued by this brief encounter. But now our view has changed. A new eye has turned its gaze toward the outer reaches of our solar system. This powerful instrument can see the universe in ways we never could before. It peers through the darkness with incredible clarity, capturing light that has traveled for billions of years. With this new tool, we are beginning to pull back the veil that has hidden Neptune for so long. The distant blue marble is slowly coming into focus. And what we are starting to see is surprising, challenging everything we thought we knew about this far-flung world. The quiet giant is beginning to share its secrets. Neptune's atmosphere has always been a puzzle. We knew it was composed mostly of hydrogen and helium, with a small amount of methane. It was the methane that we believed gave the planet its characteristic blue color. Methane gas absorbs red light and reflects blue light back into space. This seemed like a simple and elegant explanation. The Voyager 2 images supported this idea, showing a world of uniform, deep blue. For over 30 years, this was the accepted truth. Neptune was the blue planet because of the methane in its upper atmosphere. It was a simple fact, written in every astronomy book. But the Webb telescope has shown us that the story is not so simple. In its infrared view, we can see details that were previously invisible. The images reveal a bright, glowing band of clouds encircling the planet's equator. This was a complete surprise. This equatorial brightness suggests that there is a powerful atmospheric circulation pattern at play. Warm gas from deep within the planet appears to be rising at the equator, becoming visible to Webb's sensitive instruments before cooling and sinking back down at the poles. It is a global conveyor belt of heat, driving the planet's weather in ways we are only just beginning to understand. Furthermore, the new images challenge our old ideas about the planet's color. While methane is certainly a key ingredient, it might not be the only factor. The complex patterns of brightness and darkness seen by Webb suggest that other unknown chemical processes are at work. There may be another, as yet unidentified gas or haze that contributes to the beautiful blue hue we see in visible light. The simple explanation has given way to a more complex and intriguing reality. The planet's atmosphere is a dynamic chemical laboratory, and we have only just begun to analyze its contents. What is most remarkable is how clearly Webb can see these features. We can now track individual clouds as they drift across the planet. We can measure their altitude and their temperature. This allows us to build a three-dimensional map of Neptune's atmosphere. We can see how storms form, evolve, and dissipate. We are moving from a static two-dimensional picture to a dynamic living model of a distant world's weather system. The seemingly calm blue marble is revealing itself to be a place of constant churning activity, a world with an atmosphere as complex and fascinating as our own. Neptune has 14 known moons. They are a strange and diverse collection of worlds. The largest of them is Triton, a fascinating moon that orbits the planet backwards. This retrograde orbit suggests that Triton was not formed with Neptune, but was instead a dwarf planet, much like Pluto, that was captured by Neptune's gravity long ago. Voyager 2 gave us a tantalizing glimpse of Triton's surface, showing vast plains of frozen nitrogen and geysers erupting dark material into its thin atmosphere. It is one of the coldest objects in our solar system, yet it is geologically active. In the new images from the James Webb Telescope, 7 of Neptune's 14 moons can be seen. They appear as tiny points of light scattered around the planet. The most prominent of these is Triton. Because Triton's surface is covered in frozen nitrogen, it reflects sunlight very strongly. In Webb's view, it shines with an almost star-like brilliance, far outshining Neptune itself, which is darkened by methane absorption at these infrared wavelengths. This intense brightness creates the telescope's signature diffraction spikes, making Triton look like a celestial diamond next to the muted pearl of its parent planet. Beyond Triton, Webb has captured several of Neptune's smaller inner moons. Moons like Galatea, Naiad, Thalassa and Despina are visible as tiny specks orbiting within or near the ring system. Observing these small moons is incredibly difficult, and seeing them so clearly is a testament to Webb's power and stability. Their orbits are closely linked to the structure of the rings. It is their gravitational influence that is thought to confine the ring particles, creating the sharp edges and clumps that we see. Studying their precise locations and movements will help us understand the delicate dance between moons and rings. The study of these moons is crucial to understanding the history of the Neptune system. How did Triton's capture affect the orbits of the original, smaller moons? Did it cause chaos, flinging some moons into Neptune and others out into space? The precise measurements that Webb can make will help us model this dramatic past. Each tiny moon is a piece of the puzzle, a witness to the violent events that shaped this distant part of our solar system billions of years ago. The family of moons around Neptune holds the key to unlocking its turbulent history. For generations, our knowledge of Neptune was based on a foundation of ground-based observations and a single, brief spacecraft encounter. The textbooks were filled with images of a deep blue world, a simple explanation for its color, and a description of a faint, clumpy ring system. These were the facts as we knew them. They formed our collective understanding of the 8th planet from our Sun. Science, however, is not about fixed facts. It is a process of discovery, of constantly refining our understanding as new evidence comes to light. And the James Webb Space Telescope is providing a flood of new evidence. The discoveries we are making are forcing us to reconsider almost everything we thought we knew. The planet's atmosphere is far more complex than we imagined, with global circulation patterns and mysterious chemical processes that we are yet to identify. The familiar blue color likely has a more complicated origin story than just methane absorption. The planet's weather is driven by powerful forces that create unexpected warm spots at its frigid poles. These are not minor adjustments to our knowledge. They are fundamental shifts in our understanding of how a planet like Neptune works. The same is true for its rings and moons. The rings are not just faint, broken arcs, but a complete and intricate system of dust and particles, more complex than previously thought. Their structure hints at a dynamic interplay with small shepherd moons, some of which we may not have even discovered yet. The moons themselves, from the brilliantly reflective Triton to the tiny inner shepherds, are providing new clues about the violent history of the system's formation. We are, in a very real sense, rewriting the chapter on Neptune. This is what makes science so exciting. It is not a collection of unchanging truths, but a living, breathing quest for knowledge. Each new observation, each surprising discovery, opens up new avenues of inquiry. It challenges our assumptions and pushes us to ask better questions. The Neptune we are seeing through the eyes of the Webb telescope is a more complex, more dynamic, and ultimately more interesting world than the one we knew before. It is a powerful reminder that the universe is full of surprises and that our journey of exploration has only just begun. Our journey to Neptune has been a long one. It began with faint telescopic observations centuries ago. It took a leap forward with the fleeting visit of Voyager 2. And now it has entered a new and exciting era with the James Webb Space Telescope. We have peeled back another layer of mystery from this distant ice giant, revealing a world of unexpected complexity and beauty. We have seen its glowing atmosphere, its raging storms, its luminous rings, and its curious moons in a way that was unimaginable just a short time ago. The view from here is simply magnificent. Yet for all that we have learned, we are left with a profound sense of how much more there is to discover. Each answer has led to a dozen new questions. What is the source of the planet's internal heat? What other chemicals color its atmosphere? How did its ring and moon system come to be? These are the questions that will drive the next generation of scientists and explorers. They are the breadcrumbs on a trail that leads us deeper into the cosmos, deeper into our understanding of the universe and our place within it. The story of Neptune is a story about all of cosmic exploration. It reminds us that there are wonders hidden in the darkness, waiting for a patient and curious eye to find them. From the planets in our own solar system to the exoplanets orbiting distant stars, there is an endless frontier to explore. Each world has its own story, its own secrets, its own unique place in the grand cosmic tapestry. Our quest is to listen to these stories, to piece them together, and to build a more complete picture of the universe we call home. And so we continue to look up. We continue to build new tools to push the boundaries of our knowledge and to reach for the stars. The universe does not give up its secrets easily, but with patience, with ingenuity, and with an unyielding sense of wonder, we can slowly begin to understand its magnificent workings. The journey is long, and the destination is, in many ways, the journey itself. There will always be another mystery to solve, another world to explore, another layer of the cosmos to unveil. And that is a truly wonderful thing. Please like and subscribe to Cosmic Discover.